Ever wonder how a single metal bottle keeps coffee piping hot, and yet the very same bottle keeps iced tea ice cold? It is the same container doing two opposite jobs. This is the classic puzzle of the thermos. And the answer reveals a secret about the universe. The secret is that temperature is not really a thing. What we call temperature is just a measure of how fast tiny particles are jiggling. Hot means fast jiggling, cold means slow jiggling. So when a drink changes temperature, it is not magic. It is just particles slowing down or speeding up. Heat is the energy that flows between them. Heat always flows from hot to cold, never the other way around. A thermos does not trap temperature. It blocks the flow of heat, and to do that, it uses one of the strangest tricks in physics. Most people assume the bottle is stuffed with insulation, or that it contains a special cooling gel. But if you cut a thermos in half, the inside is empty. There is no cotton, there is no foam, there is no gel. What is between the walls is a vacuum. A vacuum is space with nothing in it. No air, no matter, just nothing. It is the emptiest thing in the universe. And emptiness turns out to be the ultimate insulator. But how can nothing stop something? To answer that, we need to look at the three ways heat actually moves. Heat has exactly three superpowers: conduction, convection, and radiation. Block those three and you have a perfect thermos. Superpower number one is called conduction. Conduction is heat moving by direct touch. Imagine a metal spoon sitting in a pot of hot soup. The end in the soup gets hot first. That heat then travels up the metal, link by link, all the way to the handle. It works because the hot molecules are vibrating fast. Molecules are the tiny invisible bits that make up all matter. They bump into the molecules next to them. Those molecules start vibrating faster too. The vibration keeps passing along like a wave of slow-motion dominoes. That is conduction. Touching transfers heat. Different materials conduct heat at very different speeds. Metals are champion heat conductors. Their atoms are packed tight and pass energy easily. That is why a metal spoon gets hot fast. But a wooden spoon stays cool in the same pot. Wood is a poor conductor. Its loose structure slows the vibrations down. And air is even worse. Air is a terrible conductor of heat. That is why wool sweaters keep you warm. They trap air. The fluff is mostly empty space with a little air inside. But air still has molecules. They can still bump and pass heat. To really block conduction, you need somewhere with zero molecules at all. That is the vacuum we mentioned earlier. No molecules means no bumping. No bumping means no conduction. The first superpower of heat has been defeated. Now on to superpower number two. Superpower number two is convection. Convection is heat carried by moving fluids. A fluid is anything that flows. Liquids and gases are both fluids. When you heat a fluid, the hot part becomes lighter and rises. The cool part sinks down to take its place. This sets up a loop, a circle of moving fluid. Hot rises, cool sinks, round and round it goes. That loop is called a convection current. It is the same thing that makes wind blow on Earth. It is the same thing that makes your boiling pasta bubble. Without movement, convection cannot happen. Convection needs actual matter to carry the heat along. So once again, a vacuum wins. There is no fluid to move, no air to rise, nothing to carry heat away. The second superpower of heat is now blocked too. That leaves only one more. Superpower number three is radiation. Radiation is heat traveling as invisible light. You cannot see it, but you can feel it. Stand near a fire and your face gets warm even though no air is touching it. That warmth is radiation, pure energy traveling through space. The sun warms the Earth the exact same way. Light crosses 100 million miles of empty space, and it does not need air to do it. This is the one superpower that even a vacuum cannot block. So we need a different trick for radiation. Shiny surfaces are terrible at sending out radiation. They bounce it back like a mirror bounces light. Dark surfaces are the opposite. They send out lots of radiation. That is why a black car gets hot in the sun, and a white car stays cooler. So if you coat the inside of a thermos with shiny silver, any radiation that tries to escape gets bounced right back in, and any radiation trying to get in gets bounced out. With a vacuum stopping conduction and convection, and silver stopping radiation, the heat has nowhere to go. The drink inside stays at the same temperature for hours. Not forever. The seal is not perfect. Heat will eventually leak, but slow enough to keep your coffee hot until lunch, and slow enough to keep your iced tea cold until the picnic. 3 superpowers, 3 defenses. That is the whole game. Now let us build the actual thermos, step by step. First, take 2 bottles. One fits inside the other. The outer bottle is what you hold. The inner bottle holds your drink. Between them is a sealed gap, a moat of empty space. To make that gap a true vacuum, we have to suck out all the air. The air goes out through a tiny tube that is then sealed shut. What is left is nothing, not even a single molecule. That gap now blocks conduction and convection completely. Then we coat both walls of the gap with a thin layer of silver. The silver is so reflective that radiation just bounces back where it came from. Finally, we add a cap on top. The cap is filled with foam or cork. The cap stops convection and conduction where the bottle opens. All three defenses are now in place. The thermos is complete. This design is not new. It was invented in 1892 by a Scottish scientist named James Dewar. It was called the Dewar flask. Dewar was studying extremely cold gases. He needed a container that would not melt in his hands. He realized the same design worked just as well in reverse. Today, almost every thermos on Earth uses his basic idea, a bottle within a bottle with nothing in between. Physics has not changed. We just got better at the engineering. Let us recap the whole story. Heat moves in exactly three ways: conduction, convection, and radiation. Conduction is heat passing through touch, like a spoon in soup. Convection is heat carried by moving fluids, like warm air rising. Radiation is heat traveling as invisible light, like warmth from the sun. A vacuum has no matter, so it blocks conduction and convection. A shiny silver coating reflects radiation back where it came from. Combine them and you have a thermos, a fortress against heat transfer. That is why the same bottle keeps your coffee hot and your iced tea cold. It is not trapping temperature. It is trapping a vacuum. And the vacuum is trapping nothing at all. Thank you for watching this video. Let me know in the comments if you liked it. Don't forget to like and subscribe for more.